Students, the next question is, the pH of 0.1 molar solution of weak acid is 3. What is the ionization constant? A 10 to the power minus 1, option B 10 to the power minus 3, option C 10 to the power minus 5, and option D 10 to the power minus 7. You need to calculate the ionization constant in this. So, and they have given you the pH. From the pH, we can obtain the H plus ion concentration. Once you obtain the H plus ion concentration, we know that H plus is related to ionization constant as H plus is equal to root of Ka into C, because they have mentioned it, the given acid is weak acid, H plus is equal to root of Ka into C. So once you obtain the H plus ion concentration, they have given you the concentration of the acid, so you can easily calculate the value of Ka. Let us start the solution of this. Now, they have given us pH of the solution is 3. pH 3 indicates the H plus ion concentration should be equal to 10 to the power minus 3 molar or mole per liter. We know that H plus ion concentration is related to ionization constant for a weak acid as H plus ion concentration is equal to root of Ka into C. Now, we require the value of K. Squaring both the sides, it becomes H plus ion concentration square is equal to Ka into C. H plus ion concentration is 10 to the power minus 3 square is equal to Ka, whereas concentration is 0.1. Ka is equal to 10 to the power minus 3 square is 10 to the power minus 6 divided by 0.1, that will be equal to 10 to the power minus 5. Hence, option C is the right answer. Buffers. Buffers are the solutions which resist the change in pH upon addition of small amount of acid or a base. Buffers can be broadly classified into two types, acidic buffer and basic buffer. Acidic buffer. Acidic buffer is a mixture of weak acid and its salt with a strong base. For example, acetic acid plus sodium acetate together forms an acidic buffer. Basic buffer. Basic buffer is a mixture of weak base and its salt with a strong acid. For example, weak base ammonium hydroxide, salt of ammonium hydroxide with a strong acid like HCl, that is ammonium chloride. So a mixture of ammonium hydroxide and ammonium chloride together forms a basic buffer. The pH of a buffer can be calculated by using the Henderson's equation, and the Henderson's equation for acidic buffer to calculate the pH of acidic buffer is pH is equal to pKa plus log of concentration of salt divided by concentration of acid. What is this pKa? pKa is minus log of Ka, where Ka is the dissociation constant. Similarly, for a basic buffer, you can calculate pOH, and pOH is equal to pKb plus log of concentration of salt by base. Let us solve some problems related to buffers. Students, the next question is, the pH of a solution obtained by mixing 20 ml of 0.02 molar sodium acetate and 10 ml of 0.01 molar acetic acid. Dissociation constant for an acid is given, that is equal to 1.8 into 10 to the power minus 5. So if you look at the question, they have given a mixture of sodium acetate and acetic acid. Acetic acid is a weak acid, sodium acetate is a salt of that acetic acid with a strong base. Hence, you know that a weak acid and its salt with a strong base together forms an acidic buffer. So this is a problem related to buffer where we need to calculate the pH by using the Henderson's equation. A mixture of weak acid and its salt with a strong base forms an acidic buffer, and pH can be calculated using the formula pH is equal to pKa plus log of concentration of salt divided by the concentration of acid. But they have not mentioned the value of pKa, instead they have given you the value of Ka. So from the Ka value given, you should calculate pKa, and using that you can calculate the pH of a solution. Let us try to calculate the pH of the solution. Since it is an acidic buffer, so we can calculate directly the pH. pH is equal to pKa plus log of concentration of salt divided by the concentration of acid in the buffer. Now, to calculate the concentration of salt and the concentration of acid, first you need to calculate the number of moles of salt and the number of moles of acid, then you should divide it by the total volume, because after mixing the concentration varies. Initial, the concentration of sodium acetate is 0.0 mole per liter, but after mixing the concentration changes. Why? Because you are adding 10 ml of acetic acid also. So hence the volume increases, the concentration decreases. So after mixing, concentration you should find out and then you should substitute it. First let us find out the number of moles of sodium acetate, number of moles of acetic acid, and then we will see the concentration of acetic acid and the sodium acetate after mixing, that is in a buffer solution. Number of moles of acetic acid. Number of moles of acetic acid is equal to molarity into its volume. Molarity of acetic acid given is 0.01 into volume is 10 ml. 10 ml is, it is nothing but 0.01 liter. That will be equal to 1 into 10 to the power minus 4 moles. So moles of acetic acid given is 10 to the power minus 4. Similarly, we will calculate the number of moles of sodium acetate. The number of moles of sodium acetate is given by the formula molarity into volume, where the molarity of sodium acetate is 0.02 into volume given is 20 ml. That is nothing but 20 ml. In terms of liter, it will be equal to 0.02. That will be equal to, if I shift the point, it becomes 10 to the power minus 2, 10 to the power minus 2. So it is 4 into 10 to the power minus 4 mole. So this is the moles of acetic acid and this is the moles of sodium acetate that they have given. But when you mix 20 ml sodium acetate solution with 10 ml of acetic acid, so the concentration of salt as well as the acid varies. So let us find the concentration of acetic acid. Concentration of acetic acid in the solution is given by the number of moles of acetic acid divided by volume. That is, number of moles of acetic acid is 1 into 10 to the power minus 4 divided by the total volume. Total volume is 20 plus 10, 30 ml, that is nothing but 0.03 liter. So similarly, concentration of sodium acetate, that is CH3COONA is equal to number of moles divided by volume, that is number of moles of sodium acetate is 4 into 10 to the power minus 4 divided by the volume, that is nothing but 0.03. Now you can calculate the pH by substituting these concentration of salt as well as acid. But to calculate the pH we require pK, but they have given you the Ka value. Hence pK is equal to minus log of Ka, that is equal to minus log of 1.8 into 10 to the power minus 5, that is equal to minus outside. So I will shift a point, a decimal forward, decimal 1 digit forward, so it becomes log of 18 into 10 to the power minus 6, that is equal to minus outside. Log of 18 can be written as log of 3 into 2 into 2, 3 2s are 6, 3 into 2 into 3, so 3 2s are 6, 6 into 3 will be 18 into 10 to the power minus 6. pK is equal to minus log of 3 into 2 into 3 into 10 to the power minus 6, that is equal to minus outside log 3 plus log 2 plus log 3 plus log of 10 to the power minus 6. Log 3 is 0.4771, log 2 is 0.3010, log 3 is 0.4771, log of 10 to the power minus 6 is minus 6 log 10 and log 10 is equal to 1. If you simplify this, it will be equal to 4.7448. This is the value of pK. Hence, you need to calculate the pH. pH is equal to pKa plus log of concentration of salt divided by the concentration of acid. The salt given is sodium acetate and the acid is acetic acid. So pKa value is 4.7448 plus log of concentration of salt. Concentration of salt is 4 into 10 to the power minus 4 divided by 0.3 0.03, that is the volume, divided by concentration of acid, that is the number of moles, that is 1 into 10 to the power minus 4 divided by 0.03. 0.03 gets cancelled, 10 to the power minus 4, 10 to the power minus 4. This will be equal to 4.7448 plus log 4. Log 4 is 0.6021. If you add these two terms, you get the value equal to 5.34. Hence, pH of the above mentioned solution is 5.34. Hence, option D is the right answer. Hydrolysis of salts. Salts undergo hydrolysis in water. That is, when salts are treated with water, they form corresponding acid or a base. Hence, the pH of the solution varies. The pH depends upon the type of a salt, whether it is a salt of a strong acid or a strong base, or whether it is a salt of weak acid, weak base, or weak acid, strong base, or a strong acid or a weak base. So, depending upon the hydrolysis pattern, the pH depends. Let us consider an example of a salt of a weak acid at a strong base. The simple example of salt of weak acid and a strong base is sodium acetate, CH3COONA. Now, sodium acetate, when it is treated with water, it undergoes hydrolysis to form acetic acid plus NaOH. CH3CO minus reacts with H plus to form CH3COH. The Na plus present reacts with OH minus to form NaOH. NaOH is a strong base. It will be in it undergoes complete dissociation and it will be in a dissociated form. Whereas acetic acid is a weak acid, it undergoes partial dissociation. If you consider a solution, aqueous solution of sodium acetate contains acetic acid, Na plus ion and OH minus ion, where acetic acid undergoes partial dissociation. Since it undergoes partial dissociation, the concentration of H plus ions here will be less than the concentration of OH minus ion. Since the concentration of H plus ion is less or the concentration of OH minus is more, the solution will be basic in nature and the pH will be greater than 7. That is, for a salt of a weak acid and a strong base, the solution will be basic in nature. If you consider a salt of weak base and a strong acid, for example, ammonium chloride, NH4Cl. Ammonium chloride, when treated with water, it undergoes hydrolysis to form ammonium hydroxide. NH4 plus reacts with OH minus to form NH4OH. H plus reacts with Cl minus to form H plus and Cl minus ion. So HCl is a strong acid, it undergoes complete dissociation, whereas ammonium hydroxide is weak, it undergoes partial. In this solution, the concentration of H plus will be greater than the concentration of OH minus ion, hence the solution will be acidic in nature, hence its pH will be less than 7 at 25 degrees Celsius. That is, for a salt of weak base and a strong acid, the aqueous solution will be acidic in nature. If you consider a salt of strong acid and a strong base like NaCl, when you treat it with water, it undergoes hydrolysis to give you NaOH and HCl. NaOH is also a strong acid, HCl is also a NaOH is a strong base and HCl is a strong acid, hence it undergoes complete dissociation, hence the number of H plus and the OH minus ion will be same and the solution will be neutral. If you consider a salt of weak acid and a weak base, for example, ammonium acetate, CH3COONH4, when it is treated with water, it forms acetic acid plus ammonium hydroxide. Acetic acid is also a weak acid and ammonium hydroxide is also a weak base. Hence, pH of such solutions cannot be predicted because the pH depends upon the dissociation constant, that is dissociation constant of acetic acid as well as the ammonium hydroxide. So, if we sum up everything, so a salt of weak acid and a strong base will be basic, a salt of strong acid and weak base will be acidic, a salt of strong acid and a strong base will be neutral, whereas a salt of weak acid and a weak base, the pH of such aqueous solutions cannot be predicted. But you can calculate the pH, exact pH can be calculated by using the formula. For a salt which is made up of which is formed by the combination of weak acid and a strong base, for such pH can be calculated by the formula pH is equal to half of pKw plus pKa plus log C. What is pKw is ionic product of Kw is ionic product of water and pKw is minus log of Kw. At 25 degrees Celsius, the value of pKw will be equal to 14. For a salt of weak acid and a strong base, pH can be calculated as pH is equal to half of pKw minus pKb minus log C. For a salts of strong acid and a strong base, they will be neutral, and at 25 degrees Celsius, the pH of such salts, aqueous solution of such salts will be equal to 7. For a salt of weak acid and a weak base, pH is equal to half of pKw plus pKa minus pKb. So, these are the formulas to calculate the pH of salt solution after they undergo hydrolysis. Students, let's solve some problems related to this.
ಡಿಯರ್ ಫ್ರೆಂಡ್ಸ್, ನೀವು ದಿವಿಗೆ ಯೂಟ್ಯೂಬ್ ಚಾನಲ್ಗೆ ಸಬ್ಸ್ಕ್ರೈಬ್ ಮಾಡಿ, ನಿಮ್ಮ ಫ್ರೆಂಡ್ಸ್ಗೂ ಹೇಳಿ, ಇದೇ ಥರ ನೂರಾರು ವೀಡಿಯೋಸನ್ನು ಫ್ರೀಯಾಗಿ ನೋಡಿ.